Oh, hi, fancy meeting you here at the Daily Space Weather. If you're looking for the most detailed imagery of the sun and most comprehensive space weather you'll find in the known universe, you've come to the right place. The Smash News Network, least busted name in news, and welcome to space. As we're showing you the sun all over the place. This is the past 24 hours from SDO. We've got a new exciting sunspot, which we will show you spectacularly close-up details of. You may see some activity there in the eastern limb, which would be on your screen left. Just south of the equator, that new sunspot has been active with some M-class solar flares. So fasten your space belts, fasten your Coupier belt, because we're going deep into the space weather. So there's an extreme close-up of that sunspot. That is the new most active sunspot group on the closest star. So let's show even more here. Here is the SDO intensitygram. SDO continuum. And most of these sunspot groups have been stable since yesterday, so no major changes coming. A series of rather significant groups are setting in both the northwest and the southwest. That increases the likelihood of large flares around the western limb. There's the colorized magnetogram for yesterday plus today. So again, no major changes coming with sunspots. And let's take a brief moment here to see what's going on Croissant Earth. So we like to cover volcanoes daily on the channel because of market demand. Yeah, market demand. So Mount Ibu is erupting. It's producing a 7,000-foot plume of volcanic ash as it explodes. It's a flight level 070 over Halmahera, Indonesia. Luitolo, effusive explosive eruption, continues there. Looks like about a 2,000-foot ash plume over Luitolo. Semeru, flight level 150 as Semeru explodes. It's a 15,000-foot ash plume over East Java, Indonesia. Cotopaxi in Ecuador also exploding. That's a it's a 21,000-foot ash plume there from Cotopaxi. Just a minute here. Also, Sabancaya exploding, flight level 210. And Villarrica, volcanic ash emissions there over central Chile. No indication on any kind of flight levels. Please do not pole vault the caldera. Next, looking at global seismicity. Largest quake of the past 24 was a 5.8 at Myanmar. And there's a 90-day bar graph for you. We will cite quakes over a 5 magnitude like this 5.0 off the coast of Ecuador. That was at 10:55 Universal Time yesterday, and then about a half an hour later, that 5.8 struck Myanmar. That was at 11:20 yesterday. 5.8 strikes Myanmar at 11:20 Universal Time yesterday on May 31st. There was also a 5.5 just off the coast of Kamchatka, east of the volcanic island, the volcanic peninsula of Kamchatka. Seram, Indonesia also had a 5.2. That was at 21:56 Universal Time yesterday evening. Papua New Guinea had a 5.3. And a quick reminder that any earthquake can be a foreshock, so don't assume that because you felt a significant earthquake that the shaking is done. Again, any earthquake can be a foreshock, and let's get back to space. The 10.7 centimeter radial flux is now at 161 solar flux units. And here is some more imagery of El Sol. So that is another 24-hour video there featuring ionized helium and ionized iron, 304 plus 171 angstroms from the Solar Dynamics Observatory. And here we have subtracted the 171 angstroms to show just ionized helium. By the way, there is some activity actually happening right now as we create the video. There is a CME coming from this area right here. You can actually see some of that ejecta right at the end of this 24-hour video. Right in here, right there. You can see either a CME, a coronal mass ejection, or perhaps a plasma reorientation happening there recently. Let's take a look at some more space weather stats here. The 1-year graph there, that's the 1-year graph of the 10.7 centimeter radial flux depicted by the black line and the sunspot number depicted by the red line. And we may be about to break out here. We'll reiterate why. By the way, we talked about it in yesterday's daily space weather video. If you missed that, maybe go check it out. We are also expecting a coronal mass ejection impact. It'll be a minor one on June 3rd. I think everybody else missed that one. It was kind of stealthy. So in other space weather forecasters' defense, it was rather stealthy. So yeah, possible CME impact on the 3rd. It'll be minor. It could cause maybe a KP6. It may be also occurring during a coronal hole high-speed stream. That could mask the signal or deny the signal entirely. Anyway, that's a Space Weather Enthusiast dashboard. We did see some geomagnetic unrest, mainly caused just by magnetic fields, not a major uptick in the solar wind parameters. NOAA forecasting some geomagnetic unrest or mild geomagnetic storm conditions late in the day tomorrow on June 2nd. That's from a coronal hole high-speed stream, which we will talk about here momentarily. And here is Earth's magnetic moment from space for the past 4 hours. And we've got much more significant plasma pressure. That is, this depicts magnetohydrodynamic pressure, the units of which are nanopascals. Again, that's about 12 Earth diameters there. Earth's magnetic moment from space for the past 4 hours. We've also got Earth's magnetic moment from the ground for the past 4 hours. And again, since we did have an uptick here, we're showing you the North American map as well as the global view. So there's the last 4 hours of ground magnetic perturbations for North America. Earth's magnetic moment from the ground. And here is the global view also. Let me bring that back. So this will show the most likely places to see railway, power grid, pipeline induction, telluric currents, and also the aurora. So some changes happening there to Earth's B field. And let's move into some more data. Here is your planetary K-index, a global geomagnetism average. It did reach 3.67, now dropped down a little bit to 3.33. That is still a geomagnetically calm conditions, not what I would call geomagnetic unrest. I guess geomagnetic unrest when you round the 3 to 4 at 3.67. So a brief period there of activity which seems to be subsiding. Now, we did watch the magnetic fields increase, and this is what caused that period of geomagnetic unrest. The magnetic field made it to 9 nanotesla there with a BZ of -7. So that's the vertical component of the magnetic field. That induces more current into the Earth system when we have a negative BZ. So again, that has subsided. Also, the field has been weakening since that moment. The current condition is a positive BZ of 4 and a BT, the total field, of only 5 nanotesla. Current solar wind density is just under 8 protons per cubic centimeter. Solar wind speed here slightly elevated here. It looks like a weak coronal hole wind stream. 459 kilometers per second is the current solar wind speed. Let's look at some magnetic data. Here are our geosynchronous near equatorial GOES magnetometers, measuring the magnetic field at about 23,500 miles of altitude there, and seeing some little variations happening there in the magnetic fields. It's a pretty weak coronal hole high-speed stream. And let's talk about the top view ecliptic plane field plot. So I would draw your attention to this area right here. This little green blob here, that is coronal hole of North Pole orientation hanging out. at the north heliographic pole. You can also see some changes happening to the heliospheric current sheet here. You can see this south pole current sheet popping through there, an indication that there's probably a strong sunspot about to rise in the north. So that'll be something to, that's what we call for predictive value there. So that, if you bring up the last image here, let me go back a little bit. That current sheet pops up and kind of vanishes again. That is an indication that, again, likely magnetism there in the northern hemisphere. So possibly another sunspot there rising. And this top view ecliptic plane field plot is crazy good at forecasting if you understand how to read the data. So anyway, we're keeping an eye on this magnetism right here, as that looks like it is preparing to snap away from the north heliographic polar region. When it does so, that is sort of, it's a clear path to solar maximum at that point. And you can see that is indeed shrinking over the past 4 days, which is what's depicted in that imagery. We're waiting for that coronal hole to snap into the, the equatorial region, as the solar polar field reversal for the northern hemisphere has been taking its time throughout solar cycle 25. Here's our line of sight field plot depicting the solar B field in blue, north polar field in green, south in red. And you can see that sudden change happening there associated with the heliospheric current sheet. There is, whoops, you see that little bit of B field popping out there. And let's move to coronal holes. So here's our coronal hole line of sight plot. And if you bring up the last image here, again, this coronal hole right up here is the one that we're talking about. It's important enough that we featured it on yesterday's thumbnail. We put an arrow that looked just like this, pointing at that coronal hole, as that is sort of all that is standing in the way between the current level of activity and solar maximum. Let's take a look at coronal holes here. They'll all be of North Pole orientation. Here's 211 angstroms from SDO for the past 24 hours. We've included that great Earth scale there so you can see how gigantic that coronal hole is. It is triangular in shape, which will frighten people, as shapes in nature, for some reason, are considered to be scary by everybody. So if you need to be alarmed about something, there you go. That southern coronal hole is triangular in shape, and it is of North Pole magnetism, by the way. These are all North Pole oriented coronal holes. You can see up here that one up there is the one to really keep an eye on. It might not be super well defined. It is there. The magnetic data does not lie. So let's move to sunspots next. Before we do that, please take a moment to support the channel. If you enjoy these videos and prefer to see them continue to remain existent, publicly visible, and free for all to view, why not visit our sponsor/affiliate link? Yeah, there's a paid promotion in this video, not only for the Hemp Lucid products, but also for the Amazon shop, which we'll talk about momentarily. Make sure you enter the promo code SMASHOMASH if you are picking up some Hemp Lucid products. The promo code SMASHOMASH, which you'll enter on checkout, will save you 10%. So shop via our link, which you'll find below this video in the description, as well as on our homepage, which we will talk about momentarily. Hemp Lucid products there, they come in a variety of different things like CBD creams and topicals. CBD tinctures are the most popular. CBDs for your pets. And don't forget mushroom gummies, immune stacks, and lots more. Delta 8s, dissolving strips, gummy cubes. Promo code SMASHOMASH will save you some dough. There are even some THC-free products there. Hemp Lucid, help out the channel by visiting our affiliate links. The homepage of SmashoMash.com is launched back in February of 2019. You can find links there. You can find a link to the Hemp Lucid shop, the Amazon shop, a permanent invite link to the Discord channel, and lots more. Follow us on Twitter and Instagram. If you want to see some additional content about lifestyle, diet, exercise, fitness, things like that, link for Hemp Lucid right there. Link for Amazon right there. Smashomash.com. And welcome to the Neo Renaissance. Today's featured product is, and by the way, save 20% on everything at the Hemp Lucid. At the Redbubble shop. Save 20% on everything and help us to make astronomy and cosmology science again. And of course, this is just created sort of to be a little bit inflammatory. I'm not suggesting that astronomy is not science. Cosmology, there are many people that have valid arguments about a lot of the things that are currently going on with respect to cosmology are not science. Again, you can save 20% on all of the products there. The colorful Make Astronomy and Cosmology Science Again. Today's featured product. You can find links below this video in the description to our Redbubble shop, as well as, once again, on the homepage at smashomash.com. Click the Smasho merch link or the graphical link at the bottom of the page. That'll redirect you to our Redbubble shop. Those will show you the items in order of best selling. Save 20% site-wide on Redbubble. And the Amazon featured product today, like yesterday, it's based on the coffee that I'm currently drinking. However, this one is my coffee mug. I got a set of glass coffee mugs, and I'm currently drinking out of the pink one. So check out the Amazon shop there for our coffee picks, kitchen gadgets, and lots more items there from the Amazon shop. Amazon.com/shop/Smashomash. Some cycling items, some kitchen items, even some spaceware. If you want a radiation reflecting bucket hat or boonie hat like the one I have, you can find that there as well. If you want to support the channel via subscription services and get some additional content, consider becoming a member of the Smash Team at smashomash.com/Smash Team. These videos are brought to you in part by the Gold and Silver Smash Team members. There is also a bronze membership there that'll cost you exactly $0 per month. These videos are also brought to you at massive personal risk and expense by Smash staff and I. There are only 2 people in the operation here at the Smash News Network, Least Busted Name in News. So help continue the possibility that these videos will remain existent, free for all to view, and publicly visible, as opposed to behind a paywall. Smashomash.com/Smash Team, and it's time to move to Sunspots. Now, we may have 1 or 2 more named groups here, but it's basically a stable situation since yesterday. The sunspot to really watch is 3323. It's also produced some significant flares already. Also, the likelihood of large flares certainly does exist as well in the northwest, as these groups up here set several large sunspots setting up there. Again, those are some likely spots to see major solar flares. And let's take a look at some sunspots here on some additional custom type videos. So here we've got 1600 plus 1700 angstroms. Great Earth scale there showing you how gigantic some of those sunspots are in the southwest. Once again, the most likely places to see large flares today would be number 1 over here at 3323, and then number 2, these setting groups up here. Here's some more imagery of sunspots. It's the past 24 hours in SDO continuum. We've zoomed into the equatorial region. That'll be all the sunspots. And again, no major changes here in the past 24 hours. Most of those groups remaining stable. So next we're going to get to energetic particles and solar flares, and it'll be exciting because we've got some spectacular images, as we'll keep bringing you more and more imagery as solar cycle 25 ramps up to solar maximum. So here is our GOES proton flux. No significant spikes in that. We call those solar energetic particle events. We ain't got none. As far as flaring goes, we've got some close-ups of this flare. It's like a triple spike. Peak flux was M4.29, so a significant flare there happening just a couple hours before midnight there. That is the GOES X-ray flux as measured in space by the GOES 16 and GOES 18. X-rays, they can't be measured from ground level. Let's take a look at some of our favorite wavelengths through which to view flares. Here's 94 plus 131 angstroms. So that's a full 24-hour video. You can see some flaring both in the southeast, which would be your lower left, and in the northwest, which would be your upper right. And here is the slow-mo. We've slowed this down to 1/3 speed and just included the moments around this M-class flare. We've got that in multiple wavelengths also. We'll let that play through again. That's only 10 frames per second. We're usually showing you 30 frames per second. And if you'd like some close-ups of that, I think we've got you covered. We can accommodate you. So there is just a spectacular close-up of Sunspot 3323 and the rather long duration series of flares there, including that nearly M5 class solar flare. And if that wasn't a close-up enough view for you, don't worry. Here's an even closer view. So this time frame is approximately 1,800 hours through about 2:20 this morning, 1,800 hours yesterday afternoon on May 31st through about 2:20 this morning on June 1st. And we'll be including more and more of these type of videos as time goes on, as we'll have more and more interesting stuff to show people like you. Here we've also put together 1,600 plus 1,700 angstroms. See a lot of brightening of that area as nuclear fusion is happening right there. Yeah, carbon is getting made right there. The 1,600 angstroms is ionized carbon. It's not mysteriously appearing there. It's being built by solar activity. Perhaps lattice-confined fusion is a thing that you're seeing right before your eyes. Right there out in the open. We've also got 171 angstroms plus 335. That'll show some great plasma effects. And last but not least, we've got 193 plus 211 angstroms. These do a great job of showing the extended corona and coronal holes. (193 plus 211 angstroms) are both species of ionized iron. It is part of the extreme ultraviolet spectrum. And those are some epic money shots for the day. So here's the full disk view. This is a 24-hour video back to 30 frames per second there, 131 plus 94 angstroms. Possibly a new active region rising right up here, or forming right up here. You can see some sudden brightening happening there. That's something to keep an eye on. And when I say eye on, well, pardon the pun. Here's the last 24 hours in Sunspot 3323. Again, that's the full 30 frames per second that we usually show on the channel. And I believe that is still the most likely place to see major solar flares. Let's get back to stats. We're interested in what's going on overhead, so let's take a look. This is what's happening over Lehigh Valley, Pennsylvania at the moment. And if you are looking at the sky around dusk, you'll get a great view of Venus and Mars, and also the moon. If you want to make your own sky chart, your own sky chart, head to skyandtelescope.org. That's the one we're currently using. And here is your solar system forecast. There's where heavenly bodies are located today. Here's where they'll be in 1 week. That's where things will be on June 8th. We will have a gibbous waning moon. By that point, and let's move to coronagraphs. So it's time to look for coronal mass ejections. Are there any additional CMEs headed toward Earth? Well, as far as I can see here, I don't think so. Not based on yesterday's coronagraphs. That is 104 frames from yesterday. If you think I'm incorrect, leave us a comment and let us know. Here are today's coronagraphs, 38 additional frames. We'll also show the Soho Lasco C2 and C3. Again, I think there is a CME propagating in the northeast as we make the video. As far as those CMEs go, I don't see any indication that they are earthly directed. But let's take a look at stereo A as well, because we are always prepared for the possibility of missing data. And we show that to show people the location as Earth is overtaking. Stereo B and Earth are overtaking each other right now. And stereo A is more slowly in the process of overtaking Earth. Here's stereo A's coronagraph on the left, and once again the Soho Lasco C3 on the right. No indication we've got earthly directed CMEs there. But let's take a look at our custom coronagraphs next, just to be sure. It's one of those things that you can't possibly know what's going on until you have a look. So here are our 24-hour coronagraphs. And I don't think those CMEs are earthly directed. They look like they're pretty apparent in their directions. No halo eruptions happening. But a minor CME likely on the way. And also some coronal hole high-speed streams. So we're expecting a pretty significant signal when those coronal hole high-speed streams show up. At the moment, things are still quite calm here. We've also got 193 angstroms there from SDO. That helps to show plasma moving around. You can see a little bit of plasma here. It does not appear to be earthly directed when it does eject. So it's pretty chill as far as additional space weather goes. Just a minor CME on the way and some coronal hole high-speed winds. Next, we're going to move to filaments. We've got One of the largest filaments that we've ever covered on the channel actually is moving right into the Earth strike zone. Yeah, the Earth strike zone. Look at the size of this filament, folks. If that filament ejects when it is right there, see that big dark feature there? That is a huge plasma filament suspended by solar magnetic fields, defying gravity and pointing right at planet Earth. So this is definitely one to keep an eye on. In fact, it ought to get a name after a living person. So follow us over on Twitter and follow the hashtag #NameThatFilament, and then join us to name that filament. Right there. I've got some ideas as to who to name the filament after. So beat me to it by hitting us up over on Twitter. No, you can't name filaments in the YouTube comments, only on Twitter. Let's take a look at filaments from our custom views here. So here's the southern hemisphere. And there you can see that filament. It is right behind that triangular shaped coronal hole. It looks like it's actually getting unstable here. It looks like the southeastern anchor point of that has maybe stopped anchoring it. So that could be on its way out. And when it's on its way out, it could be on its way towards your doorstep. Here's the equatorial view in these same wavelengths. You can see that filament is like 80 Earth diameters in length or something like that. That filament is larger than the planet Jupiter, at least in terms of its length. Also, you can see this CME propagating right in here, coming out of that new active region. It'll also be visible in the north heliographic view. There's also a prominence up there. I'm talking about this filament right up here. So certainly the possibility, the likelihood of coronal mass ejections is like 100% once again today. And for you new viewers, we realized that we can forecast coronal mass ejection years ago. We just stopped doing it because it didn't do anything to increase our channel viewership. So if you're not incentivized to do stuff, folks, you probably just won't do the stuff. Here's the past 24 hours in those wavelengths. These are the best wavelengths, in my opinion, to view filaments, at least from SDO. It's 193 plus 304 angstroms. It doesn't show them as clearly as the hydrogen alpha imagery does, but it does show great depth and definition to the solar corona, the sun's atmosphere. So that's why we like those wavelengths to view filaments. 304 angstroms plus 193 angstroms. Also good at showing coronal holes and active regions. Continuing right along to look at the last couple of hours here, again, because there is a CME happening. Once again, a coronal mass ejection occurring as we produce the video. So right up here, you can see some material. Whoops. It looks like it's, well, it might have splashed back down. It might be on its way out. It's just too early to tell. Don't worry, we'll keep you posted, especially if it's earthly directed. That is the past about 2.5 hours from the AGOS 18 SUVI. 304 angstroms wavelength. That brings us to bonus features, starting out with satellite charging hazards. And we do have some significant surface charging hazards here caused by low-energy electrons building up on the surfaces of satellites in the eastern Pacific. Also some minor charging hazards there over Central America and southern Mexico and parts of the Caribbean, but the main portion is the East Pacific. Some significant surface charging hazards there for satellites. Next, it goes electron flux, and it is dropped down a bit here. Again, there's been a weak coronal hole wind stream impact. It's barely enough to register very much at all. It is associated with a dip in the electron flux. There's the 1-year graph to put it in context. If you want to follow the 1-year graph of the electron flux yourself, it's available at solon.info/solar. And here's the NOAA forecast, expecting a further decrease. I would tend to agree with that forecast. And next we'll look at the F layer of the ionosphere. Yeah, the F layer. Feel free to pause the video in this frame if you're not familiar with the atmospheric layers and the temperature inversions and the electromagnetic radiation penetration. For example, the reason we have to monitor X-rays from space is because they never even make it to the stratosphere, folks. They're absorbed by the time they reach the bottom of the mesosphere. Here is the vibrational frequency. Ooh, we are seeing some significant anomalies here. So significant ionospheric anomalies. This depicts the previous day in vibrational frequency in megahertz, millions of vibrations per second. Again, some significant anomalies, which will be more apparent in the anomalygram. Now, we did have geomagnetic unrest conditions, so that does affect things basically instantaneously at the bridge between Earth and space, the F layer of the ionosphere. And you can see quite a few low-frequency anomalies happening here, and then some rapid shifts over the South Atlantic anomaly, which is something that you may have come to expect. South Atlantic anomaly located right about there over the South American continent. There's also another weak spot over here around the equatorial coast, west coast of Africa. That is sort of the weakest portion of Earth's magnetosphere. It's sort of like that. There's like a weak spot right there. And you can, of course, see on the ionosphere map the rapid variations there. This is depicting anomaly in megahertz from the 30-day median. And once that plays through one more time, we'll show the latest image. That data courtesy of Australian Government Bureau of Meteorology. There is the 11 o'clock Universal Time ionogram and the 11 o'clock Universal Time anomalygram. Total electron content is free electrons to about 12,500 miles of altitude. Feel free to pause the video in this frame if you're not familiar with distances in miles. Here is the total electron content. It's literally a count of the electrons from the inner portion of the outer Van Allen belt down to your GPS handset. So that is the most likely places to see GPS errors, and we do indeed see some electrons quite far out of place, some significant nighttime GPS errors happening there. GPS errors are most common around the equator at noontime. However, when we see things like coronal hole high-speed stream impact and CME impacts, this can be varied quite a bit, as it is now, from the minor coronal hole stream that we've been seeing. And here's the total electron content for just North America. Now, this is depicting the anomaly from the 10-day average. And we did extend the possibility that there may be a large earthquake someplace like Mexico, Central America, sometime between now and June 3rd. As yesterday we saw some significant total electron content anomalies. This is not something that we take too seriously on the channel right now, using these space weather parameters to forecast earthquakes. Is it because space weather causes the earthquakes? Well, I don't think so. I believe the signal is coming from the Earth side of things. However, if there is a signal in the space weather data, we would be delighted to be able to forecast earthquakes. We'll see what happens. Keep in mind, this is only for 6+ magnitude quakes, and it does have a window of about 4 days. So that's just a rough estimation there, and you've got to pick some part of the globe. I figured I would pick North America, as it is way too complicated, and I do not have sufficient time to look at this data all around the world. So, but there are some interesting papers about a signal appearing in the ionosphere in the form of high electron contents. So, possibility of a large quake coming, especially to like central Mexico, would be my first guess, based on the way the map looked yesterday. View yesterday's daily space weather video if you haven't. Otherwise, you'll have no idea what I'm talking about. Anyway, here is the latest intensitygram and latest colorized magnetogram. Again, this sunspot 3323 is quite magnetically complex. It is beta gamma delta class. Again, we do see some activity coming out up here. There is a new sunspot forming there, so that'll be one more named group today. Once again, the most likely places to see large flares would be in the southeast and the northwest, and also the southwest, actually, because these setting groups are magnetically complex as well. Anyway, here's your rock back before we do meteorology. And we'll start out meteorology here by looking at nullschool.net. Since the aurora was turned on a little bit, we figured we'd show the space layer. Yeah, one of the layers on nullschool.net is the space layer. It'll show you the most likely places to see. It'll show you the auroral oval estimation. Anyway, let's switch to our regularly scheduled programming here. The jet streams of the eastern world. And here are the surface winds of this side of the planet. That typhoon has moved northwest since yesterday's video. It has also weakened. We won't spend a lot of time on that. Here is the surface wind scenario for the western world. And here are the extremely incoherent jet streams over the U.S., which continue. Check out the incoherent jets over the U.S. They are all over the place, and those will be creating some weird weather patterns. It's not being created by contrails or cloud seeding or HARP. Oh, yeah. By the way, we're going to show you a jet stream forecast here in a moment. First, the jet streams over the central world and the surface winds. There you have it. Moving right along. To show some stormy situation going on here over the Mediterranean. Lots of lightning. So I figured I would show a satellite map. I figured it would actually be cloudier. But what we've got is a whole series of concentrated little storms there. So there's a satellite map. That's a great 2-hour animation. And let's briefly bring up precipitation type. So lots of rain, lots and lots of rain happening over most of Italy, for example. That's your windy.com map. They've got a mobile app you can check out. There's the precipitation type on a global basis. Pretty sweet. And here's what's going on over the Americas. It's clouds and fog depicted by shortwave radiation. Yeah, the infrared spectrum. It can show you clouds and fog at nighttime. And since it's dark over half of this map, we're not using the visible satellite. We're using shortwave radiation. 3.9 micrometers infrared is the spectra. There's the view of Crescent Earth from the NASA GOES satellite. Next, your weather.gov map. We'll briefly show you weather warnings. We've got flood warnings, as we talked about on yesterday's daily space weather video. Flood watches there in Florida, Texas, and New Mexico, and also some flash flood warnings. So if your location is lit, also some flooding and hydrologic outlook warnings there for Montana as snow continues to melt. Let's take a moment to look at that, as we have not looked at snow for quite a while. And it ain't melted yet. So let's see what's going on from Global Cryosphere Watch. We'll see what's happening in the Northern Hemisphere. So first of all, the snow mass balance is right in the middle part of the range there. It's the normal range. The blue shaded region is plus or minus 1 standard deviation from the 1982 to 2012 average. So we're average for snow mass balance. Keep in mind that does not include mountains. Snow extent is a little on the high side, right at the top of the plus or minus 1 standard deviation range for the 1998 to 2011 values. Keep in mind the snow extent is just two-dimensional. It has nothing to do with snow depth. In other words, a blanketing of just a coating of snow shows up on this graph the same as a foot of snow. Last but not least, the snow water equivalent now finally returning to the plus or minus 1 standard deviation. It was way above average. Finally now getting back into the normal range there, although still more than 1 standard deviation above normal as snow melt continues. So next, your jet stream forecast. This is the GFS 72-hour forecast for the 250 millibar wind speeds. In other words, it is showing you the jet stream, and it's going to stay incoherent here over the U.S. So for the next 3 days, you can expect to see strange weather patterns continue, as we've got parts of the jet stream that are blowing sort of in the opposite direction of normal. Again, that will continue. That's your 72-hour GFS 250 millibar wind speed forecast. Here is your GFS 72-hour total accumulated precipitation forecast in inches. Let me get out of the way of the scale there. And you can see areas there of Texas and Florida. At least for Texas, expecting about 4.5 inches of rain there. Also parts of Oklahoma. And also Montana going to get some heavy rain over the next 72 hours. Looks like it's been downgraded for Florida. Last but not least, pressure and precipitation for the next 72 hours based on the same model, the GFS. We'll also show lightning. That's the past about 10 hours. And let's see if we have any current thunderstorms. And like I said before, we certainly have plenty around the Mediterranean. So quite a lot of lightning there. Incredibly rainy over Italy. Quite a bit of lightning in Spain as well. Anyway, we do have some terrestrial strikes in the U.S. I saw one in Iowa there, just southeast of Des Moines. Some thunderstorms west of Wichita and west of Amarillo. They are pretty minor at the moment. Some heavier lightning there in the Gulf. Next time you hear thunder, check it out. lightningmaps.org. It's good stuff. And we've finally got your U.S. Doppler radar. That shows vertical motion in the air column. There's the full 50 states of ALSA, the allegedly United States of America, former nation, now Banana Republic. There are the lower 48. There is, once again, shortwave radiation showing clouds and fog. It's still dark in Arizona. And here is your water vapor map. That should help to clarify things for your weird weather when you see your Doppler radar looking strange and it's kind of tough to figure out what's going to happen. Check out the water vapor map. That will help to clarify things. We hope we've clarified things when it comes to space and Earth weather. Here's a recap. U.S. Doppler radar. Clouds and fog. And water vapor. And thanks for tuning into the Smash News Network, least busted name in news. I've spent a lot of time out of the bunker, and it's time to go back. I'm scared. I'm spooked. What about you? Anyway, while I'm gone, may that solar wind be at your back. Rescue me, bunker! Rescue me from the spooky, spooky scariness of the surface of the planet. What?